So another one of these problems that we have that's a little bit more involved looks at here. So it's got A, B, C, and D. D's missing. So I do notice that they like to ask a question where one of the points is missing. It says, so the wind speed recording gauges on a parcel of farmland in New Zealand. Okay, so we got some wind speed things, so for a weather station or something like that. Site D is missing right on its coordinates. So again, I'm going to go here. D has to be down here someplace, okay, because that's the one that's missing something. So what I want to do is I want to make sure that I kind of clue in on one of the points it has a nice horizontal line. So there's my horizontal line, and there's point B. So point D is going to be perpendicular and on the opposite side of that line. It's 2 away, it's 2 away, so D is going to be right there. All right, so write down D's coordinates. It's located at 7, 1. Calculate the area of cell B. Now, this one is something that I really, when I first did this, I did it in an incredibly complicated way. And then after I thought about it, I was like, I don't need to do that. So the area of a triangle is 1/2 base times height, if I can find a base and a height that are perpendicular. All right, what I was doing was the 1/2 AB sinus C thing, and I had to use the distance formula to figure it out. It worked, I got the same answer. All right, but I then noticed that I have this nice flat side right here, which is 1, 2, 3, 4, 5, 6 long. And then the height of this triangle is right here, all right, which is 1, 2, 3, 4, 5 long. All right, so the area of that triangle is 1/2 times 6 times 5, which is not 30, which is 15. All right, so the area of that triangle is 15. And when I did it originally, I'm going to tell you honestly what I did is I found the distance of all 3 sides, and then I used the law of cosines to figure out one of the angles. I can't remember which one. I think it was this one here. And then after I did all of that, I did 1/2 AB times cosine of C. All right, so it was a lot of work. I did 2 distance formulas, and then I did a law of cosines, and then I did a formula for the area. It probably took, I don't know, 5 or 6 minutes total. Which was I knew was way too long, but I didn't know how else to do it. So that's what I should do right there. Find the distance from point E to the nearest wind speed recording gauge. So E is 12.4. So 12, 1, 2, 3, 4 is right here. So the closest one is going to be over here at C. So I need to find the distance between C, which is 8, 6, and 12.4. So 8, 6, and 12.4. I'm going to do a distance formula. So it's square root of 12 minus 8, ugly 8, squared plus 6 minus 4 squared. All right, so I'm going to do that. Put it right in the calculator. So square root 12 minus 6 squared plus 12 minus 8 squared. I didn't think it was 12 minus 6. 12 minus 8 squared plus 6 minus 4 squared. Okay, which is 4.472. So 4.472, blah, blah, blah. All right, it doesn't say what you're round to, so I'm going 4.47. So 4.47 for that answer. All right, then it says the average wind speed at each site is given in the table below. Estimate the wind speed at point F, which is 4.2. All right, so 4.2 is right there. All right, it is closest to D. So what I would do here is I'd write closest to point B, so 9.2. All right. Now, there's probably a more scientific way to do it, kind of looking at the 2 closest ones, but that's all they're going to want for that answer right there.